64, number 5. So if you don't have a textbook in front of you that I just asked you to get out, make sure you do. Go get a textbook. There is some way back there on the table, or on the counter, I should say. If you've got lots of textbooks at your table, make sure that you share with people that don't, so that we can have enough. There should be plenty of textbooks. Does anybody have more than like a textbook per person? Are there extras? Can I have one of you two? I don't know if those are your textbooks that you've checked out, but can we share over here, just so that we've got enough to look at? Everybody able to see a textbook now? Okay. I need to ask a favor, because this is not going to go. We're looking at number 5. It's a great story about Maria. Maria's kind of a jerk, just so you know. I know, right? Got to know the character of these people. Maria throws an apple vertically upward from a height of 1.3 meters with an initial velocity of 2.4 meters per second. Can you picture this? No? Okay, so here's an apple. I'm Maria. I'm going to take the apple and I'm going to throw it from here upwards like that. Got it? No. Do you really not? Or are you just being ornery? Like, if you don't understand, then tell me. Okay. But just being obstinate isn't going to get us anywhere either. Is that okay? Yeah. So does it make sense? Yeah. Okay, good. So that's the situation. Apparently, she has a friend in a treehouse 5.3 meters above the ground. The question is, will the apple get to her friend? So what I need you to do right now is to draw a picture of that situation and write down some givens. And I want you to talk to each other about the physics and write it down. Write down your list of givens. John, you're talking to your partner right there. You guys are partners at your table. There you go. And once you've got your picture drawn, and once you've got your givens written down, work with your partner. Get out that equation sheet. See if you can answer the question. In fact, I know you should be able to answer this one. Do it. Go, go. Picture? That's kind of awesome. I think it's as high as it can go. Yeah. That's the key there. That's the key. Yeah, what's up? Yo, I want to know how far it's going to go. Yeah. I'm hoping it's going to go. What's the final velocity going to be? Higher? Are you actually trying to find displacement here? Kind of, yeah. You're hoping that it's 4. This will tell us if it's a yes or no. It starts off with a velocity of 2.4, and as it goes upwards, what happens to that velocity? What happens to the speed? Let me ask that. It's going down, right? Because it's accelerating downwards. The highest it goes speed of what? 0. So I would take these three things and solve that, find an equation that tells you delta x. Then we can see if delta x is 4. So if it's 4, then the answer would be yes, it does reach her friend. If the answer is less than 4, then no, it doesn't reach her friend. So a couple of keys here when you're doing the algebra. First is to pick the equation. It looks like most of you are doing pretty well with that. You're doing the VF squared one, right? Yeah. VI squared plus 2A delta x. We need to get delta x all by itself. So the first thing that we're going to do is what? How are we going to get delta x all by itself? Kind of peeling back the layers. What are we going to do first? Say again? Yeah, subtract VI from both sides. Squared. VI squared, right? So that's going to give you VF squared minus VI squared is equal to 2A delta x. And then what am I going to do next?
Divide by 2A.
Is that okay? Divide by the 2 and the A. So those go away, and then you can plug stuff in. The final velocity is going to be 0, so that's kind of nice. And once you've got that, then you can just plug your numbers in, right? And perhaps you realize that my assessment of Maria was accurate, that she's kind of a rude friend, perhaps not the nicest friend in the world. What did you get for the displacement of the apple? What was that? 0.29. 0.29, he says. Do you guys agree with him?
Well, 0.294.
How many sig figs do we get?
3.
3?
2.
How many do we get here? 2? I'm going to pause for just a minute because I want to make sure everybody's there, and then I want to talk about what this means. So, part of doing problems is not just like blindly plugging in numbers to random formulas, but it's actually like thinking about what it means. So let's think about what this is saying. So here's Maria. She's standing. So like I'm just going to, will you be Maria for me? Here for just a second. Just because then I can measure things a little bit better. Okay. Here's your apple. So you're going to hold the apple. Ooh, hold on just a second. Right? 2 meter stick? Yeah. All right. So you are holding the apple 1.3 meters. So that's going to be, there's 1, 2, 3. So you're holding it here. There's the apple. Everybody see that? Right? And Maria's got a friend that's 5.3 meters above the ground. Right? So that's going to be another 4 meters from here. That's like less than a meter. Is that okay? So like way up there, way up high. And ornery Miss Maria is holding that apple and she's throwing it. But how high does the apple go, friends?
4 meters.
How high does it actually go? 0.29 meters. What is 0.29 meters in centimeters? 29 centimeters. 29 centimeters, that's from here. That's 10, 29. Okay, do you see what's happening? So Maria's like, oh, you want the apple? Here you go. Here you go. Right? Like, totally mean and ornery child. Right? You get this? Thank you for being Maria and holding that frog there. I appreciate that. You see what's going on? Right? Like, that's, I just want to make sure that when you're doing these problems, you're actually thinking through what that's, because that's like, want the apple? Right? Like, that's just mean.
Maybe she's really weak. Or
Maybe she's tiny arms.
Maybe.
maybe she's
That's true. Maybe, okay, I'm sorry. I should not assume.
Maybe it's a let up. That's my
Maybe she's like
No.
2 centimeters tall and she's throwing it as
No,
hard as she
she's
can.
not, because she's holding it 1.3
So?
meters
She's
above.
standing on a stool.
On a really tall ladder. That's what it must be. You are correct. It doesn't say that she's human. Maybe she's like a mouse.
Yeah, Marie's a mouse.
Maybe that's what it is. Okay.
Confirmed.
Regardless,
You just confirmed how you-
I want to make sure that it makes sense to you that you need to look through these things. Okay? That was part A of the problem. Part B is really the reason I wanted to do the problem. It says, if the apple is not caught, is the apple going to be caught? No! And Maria's not going to catch it either. How long will the apple be in the air before it hits the ground? So, I want to do this problem with you. I want you to think about this one carefully. So this is part B. Oops, my computer's been kind of cranky today. What are our givens going to be for part B? Raise your hand if you can tell me one of the givens in part B. Go.
The displacement is 0.29 meters.
Where's the 0.29 coming from? Was that from the answer before? Okay. So I think I agree with you, maybe kind of. So the apple's going to go up 0.29 meters, so it's going to go to there. And is that where it's going to stop forever?
Oh, no.
No. Where's it going to go?
Down.
Back down to the ground, right?
Down
This.
1 point.
So what is its actual total displacement? It starts here and it ends where?
On the ground.
On the ground. What's the displacement?
Negative 1.3.
You are being adamant 1.3. Can you tell me why?
Negative 1.3.
Or negative 1.3. Like, I didn't say 1.3. Negative 1.3. Why?
Because it's going down and not up.
Yeah.
Positive down, negative.
Yeah. It's down 1.3 meters. Does that make sense? Who cares what it did in the middle? Not me. All I care about with displacement is the beginning and the end. So the displacement is negative 1.3 meters. What else have you got for givens? Acceleration. Acceleration is what? Lovely. What else you got? What else you got, Sean?
The initial velocity is 2.4 meters per second.
2.4, is that right? Meters per second?
Final velocity 0.
So the final velocity, like after it hits the floor, after it hits the ground, eventually it would be 0, right? But, and this is important too, when it just hits the ground, is the velocity 0? No. Okay? We have not yet talked about any like forces or anything that are causing things to stop, right? Besides the gravity thing that's causing it to stop at the top. So the velocity at the bottom, not 0. Do you know how fast it's moving when it hits the ground? I don't know.
Not yet.
What'd you say?
Not yet.
Not yet. Do we care how fast it's moving when it hits the ground?
No.
I mean, you might, but the question doesn't ask for it. So I'm not going to worry about the final velocity. What does the question actually want to know? It wants to know the time. Do we have an equation that has those 4 things in it? The big awesome one? Is that what you said?
Yeah.
That's what I thought I heard. Awesome. Let's do the big awesome one. So everybody's going to write it down. Here it goes. Delta x is equal to VIT plus 1/2 AT squared. Now, every problem that you and I have done together using the big awesome equation has not been that big of a deal. Because usually something goes to what? 0. Unfortunately, in this problem, looking at our givens, nothing is 0. So this is the least fun iteration of this equation, but we can still do it. Okay? In order to do this, we need to do some thinking. I generally say that you need to do the algebra first and then plug in numbers, right? But in this case, I want to look carefully at this. We've got something here, and we don't know t. But we've also got a t over here, but the t over here is what? Squared. So in order to solve this equation, we can't just get t all by itself like we usually do. Any ideas what we're going to have to do to solve for t in this equation? starts with a Q.
Quadratic equation.
Yeah. Now, my question for you is, how many of you have seen the quadratic formula? Most of you. Awesome. Here's the deal. We're going to go through it today because I want you to see it. You will not have to do it on a test. Okay? You will have to use it today in class. Hold on, let me finish my statement. Is that okay? You will need to use it on the problem set. Okay? And there will be an opportunity for you to use it in chapter 3. Okay? But again, you will not have to do it by yourself on a test. Does that make sense to everybody? Okay. So I don't want you to freak out a lot, just a little bit. And if the quadratic formula is something that you're not super a big fan of, we're going to sing songs and it will be okay. And know that if you take good notes today, then it shouldn't be a big scary deal later. Fair? Question?
I was going to ask if you're going to do the song. Okay.
Oh, of course. You can't do the quadratic formula without the song. All right. We're going to sing. You just wait. You just wait, my friend. It'll be great.
It's a great song.
Okay, so a quadratic, for those of you that either don't remember or just need a nice little refresher or didn't know in the first place, is an equation. It's a statement that has a form that looks like this. ax squared plus bx plus, oops, not bx squared, excuse me, bx plus c is equal to 0. And we want to solve that for x. Okay? In our case here, we actually want to solve for t. So t is like our x. So the first thing I want to do is to rearrange this equation to look like this one. Does that sound okay? I want you to give it a shot. We're all using pencil because pencil always erases, right? I want you to give it a shot, see if you can do it. Okay? I'm going to give you just like maybe a minute and then I'll come in and help. Try it out. How did we do? We kind of get there?
Wonderful.
I don't know how to start.
Okay, well let's talk about how to start. I want to get the thing that's got the squared first. Which thing has the squared in it? The 1/2 at squared thing? So I'm just going to rearrange this and write the 1/2 at squared first. Is that okay?
Yes.
The next thing that comes in this equation is the thing with just that one variable. And that's this one there. So really I'm just going to rearrange those two first. Just going to switch the order. Am I allowed to do that?
Yeah.
Okay, I just want to make sure that I'm not like being a really bad kid. Okay. And then the last one is the thing without any variable in it. That lives over here right now. How do I get it to the other side? I'm going to subtract it, right? So it's going to be negative delta x. And if I subtract a delta x from the left-hand side, what am I left with on the left-hand side? 0. Is that okay? Okay. Is anybody, did you say no?
I mean, no, is that just what you have to do?
Yeah.
Oh, I overcomplicated it. Okay.
So is that okay? Is that good? Everybody all right? We're all still here. Okay. So these guys look very similar, yes? Yes. Okay. So now we have to recall and remember how to deal with this thing. And the rule is that we just get to sing a song. You sound so excited back there. Wow. Now, I have to tell you that there are multiple versions of this song. Different math teachers in this building teach it with different songs. The song that I know and love is the Pop Goes the Weasel version. So is that the version you're thinking of, Zach?
I think so.
Okay, good, because I'm hoping that I'm going to not disappoint you because he just seems so excited that I don't want to make him sad today. So I'm going to teach it to you. I will sing it with whoever would like to join me the first time. And then I'm going to insist that all of us sing the second time. So even if you don't know it, that's okay. You're just going to write it down with me now. Here we go. It goes. X equals opposite b plus or minus square root of b squared minus 4ac all over 2a.
Yeah.
Yes! Wasn't that awesome?
I'm not sure
The
what
best song.
What just happened? That's right. That's why we're doing this. Woo! All right. So,
This is something I don't know what.
in your math classes, in your upper level math classes, you will actually go through and prove actually works for a real good reason. But for us, we're just going to say, sounds good. So let's sing it one more time so we get it kind of in our head. We understand how to do it. And then we'll talk about how to plug stuff in and we'll actually make it happen. Fair? Okay, so now Jake is going to join us. And Maggie's going to join us. And she's like, no, what? Everybody's going to sing. If I don't hear everybody, we're going to have to sing it over and over. So let's sing it one time. Here we go. So I'll point at it as we go. Ready? Everybody ready? Get your voices ready. Everybody ready? All right, here we go.
That's gonna be really loud.
I want not. It doesn't be loud.
No,
It needs to be
that's
nice, appropriate, right? Like.
Told me to do sirens.
All right, here we go. Is everybody ready? Yeah. Okay, here we go. X equals opposite b plus or minus square root of b squared minus 4ac all over 2a. Ah. How you doing there, friend?
Great. Peachy.
Who didn't sing?
Megatron. I know you did.
I did.
Okay. Maybe I'll make y'all come up here and sing it like a solo or something. I don't know. All right. Why do we care? How does this work? Let's figure it out. So this thing that says A, whatever that coefficient is, goes in everywhere in this equation where there's an A. The thing that says B, that coefficient, goes in everywhere that says B. So that would be here and here. Do you see what I'm saying? Does this color coding maybe help a little bit? I don't know. Is that okay? And then the C goes in right there. So if I were you and I was approaching this problem, and hey, I'm going to do it right now too, I'm going to figure out what A is, like a value. That thing's going to be 1/2 of negative 9.81. So that's going to be 4.9-ish. Boom. And then we're going to figure out what goes in there. Oh, wait, we know that one. That's just going to be 2.4. And then we're going to figure out, and this one's important, the C one, you have to really pay attention to that negative sign. So the value that goes in for C is actually going to be negative of negative, what was it, 1.3? So it's actually going to be 1.3, positive 1.3. We okay there? Now you need to get your calculators out. You can try to do this all in one step. You can do it in 17 steps or anywhere in between, but you do need to pay attention to order of operations. How many answers are you going to get? 2, because it's plus or minus, right? One of them will make sense, the other one will not. Okay, it'll be a negative time. I'm going to give you a moment right now to try it out. I want every single person to plug it into a calculator. Everybody do it. These are the 2 times that I got when I plugged it in. Not sig figs happy yet, but just those are the values that I got.
Wait, where'd time come from?
Because that's what I'm actually solving for. Right?
Is that what I'm solving for?
Yeah. Well, I don't know. That's what you should be solving for.
Well, now I'm confused.
Because you were solving for x? Is that why you're confused?
Yeah.
But the x in this equation is like the time in this equation. Huh? Do you want me to say that again, or are you okay?
I don't think I was paying attention very well.
Let me answer another question. I'll come right back. Think about it. Go.
Can you scroll up a little bit?
Of course. How far up do you want me to go?
That's good.
That far? Okay. So the equation that we were trying to solve had t's in it. a t and a t squared. The equation that we're familiar with from math has x's. So instead of writing x's, we're writing t's. Do you see what I'm saying?
I think so.
Because otherwise we'd have to sing the song like over and make it weird, like t equals opposite vi plus or minus square. Like it'd make it really confusing.
So I'm using the same equation, right?
Yes. So wherever you see the blue thing, you're going to plug in the blue thing. And the yellow thing's going to be the yellow thing. And I guess I didn't highlight that green, but yes.
Because there was t squared and t from quadratic.
How's it going?
Good. Can I read that? I think I plugged in the numbers wrong.
Okay. So my question for you is, are you doing okay?
Oh, it's negative. I think that's where I
Can you tell me why you say no? Like your numbers just didn't work?
Yeah, you got a negative square root.
Oh. Okay, so probably, because that happens to me all the time, probably it's because either you didn't put this one in as negative, or you did put this one in as negative. Neither of those is the case? You put them in the right way, are you sure? And did you put parentheses around things? I don't know. I'll come look in a second. It's time to go. So we know that a vector has both magnitude and direction. If I was going to draw something that would look like a vector, it would need to have both a magnitude and a direction on it, right? Like that seems logical. An arrow is a really lovely choice. The length of the arrow indicates its magnitude. So if I have this vector, I'll call it A, and I've got this vector, and I'll call it B, we know which one has a bigger magnitude. What does magnitude mean? Size. Which one has a bigger size? Oh, come on, friends. You can look up here. Can you tell? You don't need a ruler, do you? Yeah, A is bigger, right? Right? Are you okay there?
Yes.
Did I totally blow your minds with that, or? Yes, I totally blew your mind. Whoa, it's so long. Yes. Okay. The length tells you the magnitude, and then this kind of is a circular statement, but the way the arrow points indicates its what? Direction. Okay. When we talk about these vectors, we do a little anatomy project as well. This is as close to biology as we're going to get in here. Okay. Dissect the vector. The top part of it where the arrow is, that's called the head of the vector. And the bottom part, the part with no arrow, kind of like with a coin, is called the
Tail.
Yeah. So then we can be oriented and we can figure out what's going on with those vectors and we can speak with common language. Okay? We mentioned in the little quiz conversation that sometimes we're going to add these vectors together. We're going to put them together. When we add vectors, the way we do this is that we line them up head to tail. Okay? So it's like we get to draw little pictures now. It's kind of fun. We line them up head to tail. And the answer, which is the what word? The resultant, yeah. The resultant is going to go from the tail of the first to the head of the last. That's kind of the mantra that you want to get in your brain. Tail of the first to the head of the last. That will tell you the resultant. It's very theoretical until we actually try it. So let's try it now. Carrie Ann, it's your lucky day.
More Muppets. More Muppets.
More Muppet problems today for your birthday. I wrote them just for you, just for today. Here we go. This one's pretty straightforward. This one you probably can figure out even without really doing any real physics. But I want to do good physics with it so that when we get to harder problems, I don't know, like problem number 2, it won't be hard. I don't know why Kermit is pacing, but he is. Kermit walks 15 meters east, then 10 meters west, and then 7 meters east. Again, I don't know why, but he did. Okay? We want to know what is his total displacement. So you might be able to figure that out in your brain. Good for you. But I also want you to draw a picture. Draw a picture, work on it, talk to each other. Right now, go. And then we'll compare our answers in just a moment. All right. Did you draw a picture? Did it have some arrows?
Yeah.
They're pretty cute, right?
No. Yeah.
Maybe you need to work on drawing cuter arrows then. I don't know. My arrows are going to be pretty darn cute. All right, so he's going to start from here. Where's he going to go? 15 meters. So I have to get out a meter stick and actually draw 15 of them? No, but when I draw my arrows, I want them to be kind of relatively nicely sized. So if I draw my 15 meters like this, then the rest of my picture is going to be so small nobody can see it, right? So let's make it, reasonably sized. So maybe like that. There's 15 meters. I'm going to call that vector A. After vector A, what happens?
Vector B comes in and goes 10 meters west.
Vector B comes in and goes the other way 10 meters, right? Now, usually I'm going to draw these right on top of each other, but because it's all in one dimension, one direct, you know what I'm saying? It would be kind of confusing. So I'm going to do it just right below, just so that it's a little easier to see. So I'm going to go down here, and am I going to go all the way back to the beginning? No, about how far?
2/3.
There you go. Working on those fractions today. 2/3 of the way back, right? So like maybe about to there. And again, I don't have to measure it, but I want to get, something pretty darn close. So something like this. There's my vector B, 10 meters west. And then what? Turns around again. Oh, I did have my hat on my head. Silly me. And how far does he go this time? Did you say enough? Who said enough?
I said another.
Oh, another. Another 15? Let's read it. What does it say? 7. Oh, you guys. And by that time, he was tired and stopped? I don't know.
Sit down. Done.
The resultant is going to go from where to where?
The tail of A to the head of C.
Yeah. So I'm going to go from the tail of A to the head of C. So there's my resultant vector. What's the magnitude of the resultant vector? I'm going to call it R.
A plus B plus.
Is it just 15 plus 10 plus 7?
Well, minus B.
Well, it's going to be negative 10.
So 15 minus 10
Plus 7.
plus 7, how much is that?
12.
12. 12 what? Oh, and so that's the magnitude, but then I also need the direction. So what direction am I going to pick? Okay. So I really, really like it when you participate, but I also really like it when you participate well. So saying like random things that aren't helpful is very distracting to me. Probably distracting to your classmates, so don't do it. Thanks. Okay. Example 1, we okay? Let's make it more fun. Example 2. Do you all know who Beaker is?
No.
I feel like I need to put some pictures up here, and I keep forgetting every year. So Beaker is the one with the really, really long face. And he's got the little orange hair on the top, and he says, me, 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 me. That's all he can say. Okay? And, right, it's awesome. And he works in the laboratory with Bunsen Honeydew, and he's like the lab assistant. So Beaker walks 4 meters north, then 6 meters east. Oh, so we're mixing it up a little bit, right? And then 12 meters south. The question is, what is his total displacement? We need to draw a picture, right? I'm going to kind of walk you through this one. I want to make sure you're doing this very, very carefully. So make sure you're with me here. I'm going to go ahead and draw an axis just to kind of help me see what's going on. 4 meters north. So from my origin, I'm going to go 4 meters north. There's A. And then from that point, where am I going?
6 meters east.
6 meters to the east. He's going to turn directly east and go 6 meters so that the arrow is going to be a little bit longer. Oops, that's not C, that's B. And then from there, where's he going? South. How far south does he go?
Whoa.
A long way, right? He was up here, and now he's going to go way down here. Okay, go ahead and draw that. And then draw the resultant and check with your neighbors, see if they agree with you. Where does that resultant vector live? Where is it?
The 0, 0 to the
0, 0. So the tail of the first to the
head of the
head of the last. So that's C, right? So there's my resultant vector. Life is good? In order to figure out his displacement, because displacement is a vector, we need to know both the magnitude and the direction. Let's start with the magnitude. Help me out. How can I figure out the magnitude? You don't have to tell me the number, but how might I figure it out? What'd you say? Somebody said something. Pythagorean theorem? Pythagorean theorem works for right triangles, doesn't it? That's a trapezoid.
Is that something in the book, like you gotta add something?
Got a what?
You gotta do something to it to make it a triangle.
Oh, okay, let's make it a triangle. Does anybody see any nice right triangles in there? Yeah, where do you see a nice right triangle?
R, C on the x-axis.
Oh, like here, right? Is that what you're saying? Yeah. This is a lovely right triangle. Do we know the length of this side here? Yeah, how much is it? 6. Do we know the length of this side here? How do you know it's 8? I don't see any 8s up there.
12 minus 4 went up 4.
So up 4 and then down 12, so that leaves you down a total of 8, right? And so then my clever geometry friends say, oh, that's just a nice little Pythagorean triple, isn't it? 3, 4, 5 right triangle. Anybody? All right, except it's 6, 8, so that's going to be 10. If you don't know what I'm talking about, you're like, what is that? Then we're just going to use the Pythagorean theorem. 6 squared plus 8 squared is good as 100, and then you square root that, and that's 10. So the resultant has a magnitude of 10 meters. Would anybody like me to go through that? I'm sorry, I went really fast. Should I go through it? Okay, sorry. And please, please, please ask if I'm going through something that doesn't make sense. So the resultant squared is going to be equal to 6 squared plus 8 squared. Is that an okay statement? Okay. So then I'm going to need to square root it. So that's the square root of 36 plus 64. So that's R is the square root of, so that's 100. Just always have to make sure that I'm not making a silly mistake. And that's where my 10 comes from. Is that better? Okay. Other questions? Are we okay so far? So am I done? No, because it's a vector, right? And a vector has both magnitude and...
Direction.
Oh, yeah. Now, what is the direction? Southeast. Everybody wants to say that. Southeast. Now, I need to be very specific. Let's say that Beaker went on a walk and he got lost. Oh, no. He got lost. And he calls Bunsen Honeydew for help. He says, hey, help me, help me. I'm 10 meters away. How many different places can Bunsen look? 360? Plus all of the half degrees, right? And all of the quarter degrees and all the third, so an infinite number of places all the way around that circle, right? If Beaker says, hey, I'm 10 meters away, southeast of you, how many different places will Bunsen Honeydew have to look? And a fourth of infinity is still an infinite number of places, right? Every single place along in that quadrant, he would have to look. he wants to be specific. Because how many places is he in?
One.
Just one, not an infinite number, right? He's in one spot. So we need to say not only is he southeast, but he's exactly where southeast. So we need to include an angle. Okay? Now, some of you have done this a lot. For some of you, this is brand new. I'm going to teach it to the brand new people right now. Okay? Stay with me. If you already know it, just sit tight for a minute. We're all got to get caught up. Okay? Or maybe it would be a really good review because for some of you, you've learned it, but it's been a while. You haven't used it for a while. I need to know an angle. The angle I'm always, always, always going to look for is from where I started and relative to one of the axes. So this theta would be fine. Who y'all met theta, by the way? I should ask that first. Let me introduce you to theta. Up here, you see the thing that looks like an H? It's not actually an H, it's an eta. What? It's a Greek letter named eta. Say eta with me.
Eta.
Eta, it's spelled E-T-A in Roman letters. Eta. And the one right next to it is theta. T-H-E-T-A. Theta. Okay? So theta is a Greek letter that we use often for an angle. Okay? It's not anything special. We could call it X or Y or M or Q or anything we wanted. But generally when we talk about angles, we'll talk about theta. And there are a few others that we pick for some of those too. But I'm going to use theta. So now I have to say theta with me. Say theta for me.
Theta.
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 It's not theta like frog. It's theta like thick or thin, I guess, are two words that start with that sound, right? Theta. Okay, so that's theta, and I need to find that value. Now, there are some really lovely functions that help us to do this. Okay? So here we go. So I want you to write this down if you've never seen this. If you have seen this, you can write it down with me too, or you can just sit tight for a moment and bask in the glory of knowing this. But don't be a jerk about it. Just sit there and love it for just a second. All right, here we go. I'm going to draw myself a right triangle. I'd like you to draw yourself a right triangle also. A right triangle is unique because it always has what?
90 degrees.
A 90-degree angle. How many 90-degree angles? Just one. Could you have more than one 90-degree angle?
No.
Can't do it. Whoa, hello. So I'm going to mark my 90-degree angle, and then I want you to pick one of the others, and it doesn't matter which one, and I want you to write the letter theta next to it. I'm going to pick this one up here. You could pick the other one. It doesn't matter. Now, when you have met a right triangle before, if you've not done this before, you know that this is always called the what? Hypotenuse. We all know that. Yeah, we learned that a long time ago maybe. Right? So here's the hypotenuse. And the other two sides you've always just called legs. There are two legs and a hypotenuse. We know that. But now in this new process, we're going to differentiate between the legs. One of the legs is always across from theta. Do you see that? Like it is not touching either of the sides of that angle. It's across from theta. And that one we're going to call the opposite side. So it's across from theta. Okay. That leaves just one leg left. So we have the hypotenuse. That one's across from the right angle. We know that. We have the opposite side. That's the one that's across from theta. And then we have one that's right next to, like sitting right next to theta. And the word we use for that one is adjacent. So the adjacent one sits right next to it. It's like, hello, I'm right here. Okay, it's touching that angle. So far, so good? Okay. So there are these things called trig functions that relate these three sides with theta. Okay? In math, you'll derive it, you'll understand why and all of that, but for our purposes, we're just going to write down a really crazy word. Are you ready? Here it comes. Here's the word. There's the word. If you've never seen that word, you're going, that doesn't even look like a word, Miss Carbling. I know it doesn't. It's a mnemonic device, right? It's the word SOHCAHTOA. Say it with me. SOHCAHTOA. SOHCAHTOA. Yeah, it's like weird. Like, what is that? But it's just to help you remember these trig functions. Whatever that means. Okay? So, we have the first part. So, SOH. The S stands for the trig function called sine. And this says that the sine of theta, excuse me, my nose is stuffy, is equal to, well, we just read this. O, which is the opposite, divided by H, which is the hypotenuse. Okay? So it's going to be opposite divided by hypotenuse. So far, so good? The next one, ka. Well, the C stands for cosine. And this is funny. I have to clarify this. Sine is actually spelled S-I-N-E. We're just lazy. So it's not sin. A lot of people want to say that's sine. The reason we write it with just 3 letters, even though that's just one fewer, is that cosine gets longer, right? Because cosine is C-O-S-I-N-E, and that's like a lot of letters. The cosine of theta is equal to, well, what does it say? A. So A would be adjacent, and H would be hypotenuse.
You know, Beaker's lost.
Yeah, he's okay. He's having a good time. It's not cold outside. It's okay. TOA. Let's write it down. Stay with me for just another second here. What does the T stand for in TOA? Tangent. So it's T-A-N-G-E-N-T is the word, but we mark it T-A-N. The tangent of theta is equal to opposite over adjacent. Okay? Put a little box and star by that, and we will finish this problem, I guess, on Wednesday, because on Monday I will see you for a test. Okay? If you have any questions, please let me know. Otherwise,